gonna go. Okay. Everybody, welcome to the Fireball Machine Shop. Today we're gonna have some fun live, and I'm gonna be building a Fabricator's skill test right here live on camera so you all can see, and I want to show how to defeat this test. Now, as we go through this process, I'm going to be showing you how the fixture on the new Dragon Wagon table. This is the brand new small table line that we've developed, and this is a good option instead of the big $1,000 or $10,000 tables. So let me walk you back from the very beginning why I want to do this live. But before I do that, I need to kind of start back a year ago and give you guys a little bit of heads up on where we're at. Now, I did a video about this time last year where I did a fundamentals fabrication video, and I showed a lot of you guys on YouTube how to build a simple square, something like this. Now, and all the problems that can, I don't know, come up when just trying to build something as simple as this box. Now, to my surprise, what happened out of that video, it caught me off guard. And as I was trying to be very helpful and show you a solution to some of these problems and suggesting a fixture table, what came out of that was an interesting conversation, and that is that a fixture table is not necessary to build a simple box frame, just like this. Now, I would agree with you. It is not necessary, but I do believe that a fixture table is easier. So there was a lot of comments and a lot of feedback on the forum about this topic conversation. So I decided that I would hire professionals that didn't have a fixture table to build me the simple box that I had built in the video, and just to run my own experiment. Now, and I paid full price for these products and these parts. And to my surprise, what came back wasn't what I built on the fixture table, like in the first video. They're all out of size. As you can hear probably in this, they're teeter-totter, they're warped, and it wasn't built to the drawings. Now, after that video aired of me showing what happens when the fabricators maybe didn't take this job seriously, or they just didn't care, it inspired a new test. And speaking with everybody on the forum, we kind of developed this. A lot of everybody said that the fabricators at those fab shops didn't take this product or this project seriously because it was just too easy. It was just so easy, they just didn't care, and that was the problem. So we decided that we're going to make something more complicated, and this is the outcome. It's the same box that we'd built previously, but with 4 legs built on it. I know from looking at this, like Jason, this is still easy. What is the problem? Well, there's some built-in booby traps into this system right here. And as you can probably see, there's no supports going around these legs. The box frame can still be twisted or warped. There's some welds right in the middle of tubes that can pull or push or pull. And so this is, to me, a really good fabrication test, especially if you're a new welder. This is something you can build on your own. And 2, we need to build 2 of them that match. And that is often the problem, trying to duplicate the same thing you've already done. Okay, so that's where we're at today. I hired 3 more individual fab shops separately from this one to build me 6 frames, and they also did not come out to the drawings. Now, part of that whole system and that whole experiment was to build to fairly tight tolerances. Now, what is a fairly tight tolerance? Well, I called out for a plus or minus a 1/16 of an inch. And I did some polls on the Fireball forum and asked everybody, is this a tight tolerance? And the overwhelming response is no, this is pretty standard. This is not a tight tolerance that needs extra attention. So this is pretty standard stuff. But unfortunately, all the fabricators that built me this test did not follow those parameters. So today I want to use the small Dragon Wagon and build this exact same thing that I had the fabricators build for me. And I want to use some fixturing fundamentals and show you how I would do it. And I'm purposely going to mess up on this and show you how we can fix it. That way it's a real life scenario. And I want to do this in a way that will showcase profitability, which means there's a lot of discussion that a fixture table is not profitable. It's going to take me too long to recoup my money. It takes too long to fixture. So when I build this, I'm going to set this clock up that's behind me, and we're going to time myself and see, can this job be profitable, and we'll go from there. So first off, the material that I've used has already been cut. And just for time's sake, because I don't want to move the cameras around, swinging around to the bandsaw, this took me 20 minutes to cut all the material. And I've beveled it, so whatever we do on the time clock behind me, we are going to be adding 20 minutes to that, okay? And this cutting material is going to vary for everybody else anyway, but it took me 20 minutes. Okay, the material cost, this was 1 stick of 2x2 square tubing, and that's roughly $100 for me to purchase. The cost to have 2 of these made at a professional fab shop cost me roughly $500. So I have a $400 profit margin that I need to try to find some success in. And when we're all done, we will QC the parts and measure them, and we should be within spec and have 2 match sets, okay? And we might even compare them against the other fabricators as we go. This is by no means trying to toot my own horn. I just think there's a lot of skill, there's a lot of learning, there's a lot of education that I can teach and pass on to you, and I want to share that with you guys. I don't want to die keeping all this information to myself. I want to share it with everybody. So that gets me back to the live. We're doing this live because I don't want you to say I'm cheating. I'm going to be talking to you along the way as I go and explaining what I'm doing. So this might slow me down a little bit. I'm probably going to take a 20-minute penalty by talking to the camera, but I'm okay with that. I'm going to try to do this under 3 hours. I would like to try to shoot for 2 to get these accomplished. I don't know if it's going to happen or not, but we're going to try, okay? I'm not going to be working at a really brisk pace. I'm just going to be working comfortably, and hopefully you guys follow along. You're more than welcome to ask questions. I don't know if I'll be able to answer them, but what I do want to do is I have the forum open on the Fireball Tool website with a forum post about this live stream. And when I'm done with this project, I will jump onto the Fireball forum, and I'm going to be there answering questions for an hour or 2. So that's one way we can continue this topic of conversation. That way, anybody who sees this, we can continue to search for these questions and answers, and that this video doesn't get buried in the YouTube algorithm and nobody will ever find it ever again. So that's where I'm going to be. But Conrad's behind the camera for me, and he's going to be monitoring, make sure the cameras and the lights and the audio is staying good for you guys. We might even pan around with the camera to keep things in view. If there's a problem, let us know. Keep tabs on my audio. Hopefully I get thumbs up from Conrad saying audio is good, and he says it is. So I think I'm getting ready to get ready and get started. If there's no objections from the audience, and if we have enough time, everybody's here, let's get rolling. So I basically have these drawings memorized, so I really don't need any drawings to build this. But before I get going, I'll give you a brief size. We got 20 inches wide by 22 inches tall with 4 legs from the surface of the table to the top of the legs 15 inches. Okay, they all need to be perpendicular, plumb, straight. Everything from legs, I have a 1/16 of an inch left, 1/16 of an inch right, 1/16 of an inch over, 1/16 of an inch back. The teeter-totter, or the twist in the frame, I need to hold within a 1/16 of an inch. Okay, so not unrealistic expectations, but we need to be paying attention to what we're doing. So those are some quick measurements to go by. If you want to actually look at the drawings, those are on the Fireball Tool forum also, and you can download those if you like to build your own. Okay, so, and remember, I have to build 2. Whew. Okay, take a deep breath, and I have a timer set behind me, and then we'll turn and burn, okay? I'm not going to be working too fast like it's a race. I'm just going to be working at a consistent pace, okay? I'm going to try to talk to you as I go, and hopefully I don't screw up too bad, because this will be embarrassing. But we'll fix it no matter what happens. Okay, ready? Get thumbs up from Conrad. Okay, thumbs up from Conrad. It says we can go. Let's start the stopwatch. Okay, 3, 2, 1, go. Go, go, go. All right. Okay, so I'm going to be breaking this table down into 2 components. I don't want to build a big giant fixture to put all the pieces all in all at once. I'm going to try to isolate some problems. So I'm going to start with the leg first, and I want to build the table and isolate the T-joint, okay? So by taking the joint as this, I want to build the T first. Now I know from looking at this that when I weld on the 2 sides that these are going to fold up. and I'm purposely not going to fix it. I'm going to bow them on purpose, and then this is the real world scenario where most likely you're not going to catch this and you're going to have to fix it afterwards. So I'm going to replicate that condition, and I'm going to warp this tube, and then we'll find a way to fix it, okay? So I don't want you to say that, Jason, you're cheating, you knew that was going to warp and you're doing this all too fast, and I'm going to purposely screw up. Okay, so we have an overhead camera so you guys can see what I'm doing. What I'd like to do is I need to isolate the endo of this. I want to stop so I know where this end of the leg goes. I have 8 of these joints I need to do. Okay, so the way I'm going to start off here is with a couple blocks. I'm just going to grab all my fixtures, just put them over here on the table. No, I'm going to put an end stop here that I can butt the tooth block into. This is going to make sure I get everything the same. Okay. I don't know if this is in the right spot. I'm just going to leave it loose for right now, but it's here. Okay, I'm going to put the tube here, tube here. So the beauty of these blocks is that if you have material that's exactly on inch, like 1 inch, 2 inch, 3 inch, you can use the blocks to fully capture the tube. That's what the beauty of these fence blocks. See, it's captured left or right, can't go any direction. I don't know where the endo is going to go yet, but the tube is kind of located. I'm going to be looking at the weld seams. Where my weld seams located, I want them to be on the inside of my box. So that's something I'm also looking at. Okay. I'm going to set a couple more stops up here for this tube. I need this tube to be square. Okay, so I'm going to put this block here, and I'm going to put this block here. Like that. Looks like that's where this is going to need to go. So we'll put this, I need from the base of this to the face of this 15 inches. Okay. So we'll just pull a dimension here. Looks like I need to bump this back. It's the beauty of the fixture table is that I have a lot of control here. Nothing has to be in the right spot when you first get started. There we go. Okay, so from there to there, you can see I'm exactly 15 inches. Okay, I'm only using the tape measure for reference. This tooth block has teeth in the back of it that actually gives the correct alignment. Okay. Now where I'm at here is I'm building the box, so I need these angles to be facing up towards me. I want to make sure that my weld seam is right here. I want that to be at the top or the bottom, as long as they're consistent. I'm aware of this, where my weld seams are, so it looks visually nice. Okay. Now what I want to do is I need to locate this side to side. So this is a 20 1/4 chunk, so I need to have 2 end stops to center this up. I don't want to have to scribe any lines, do any layout, because I got 20 of these things to do. So I'm going to set up some permanent stops. Might seem like it's taking a little bit longer than normal to do this, but I assure you that when you have 8 of these to do, that it will be faster than laying them all out simultaneously. Okay. So I drop these pins in. If this is the first time you're seeing how these work with the Dragon Wagon, all the tooling is the same as the big tables. The only thing we need to have this to work is this 1/2 inch spacer. So if you ever do decide to upgrade your table, that all the tooling is the same. How we doing, Conrad? Everything's sounding good and okay? All right, he's giving me a thumbs up. Everything's sounding good. Comments are coming through, I'm sure. Yep, okay, that's good to hear. So this is 20 and, make sure this is my 20 1/4, yep. So from this edge to this edge, I need to be 20 1/8. So I'm just gonna pop this back. There we go, 20 1/8. Yep, that one's already set. Now what I'm gonna just do is I always just like confirming with the tape measure. I'm not actually using the tape measure for any measurements. I'm just using it for reference. Just to double check myself. The table is the real measuring tool here. Okay, that's it. we're located. I have a little bit of slop in my tube because I cut my tubes a little short on purpose. So I'm just gonna eyeball and do a couple quick measurements to get it centered up, and then we can clamp everything down. So that's it, we're done. We're ready to basically shim everything up and we can get welding. That went pretty fast. What I like to do is I like to shim everything up off the table 1/2 inch or so. This is just standard practice. These are little shims, and these shims go underneath the tubing, and it elevates the work up. I like to have these shims perpendicular with the tubing because this is going to set the roll. If you set them like that, this tube could roll on top of it. Okay, and if we take a quick look at the other pro shops that built their frames, they have a lot of roll in these legs. And I should pop that up and show you guys. And I question, like, why are they rolled? They're doing something wrong. This shouldn't have to be. Everything should be square and perpendicular to each other and not rolled. And so we're going to pay attention to that as we build mine. Okay. Doing for time, 6 minutes. Okay, we're 6 minutes in, and we're getting ready to put some clamps on, and we're going to start welding here. Okay, so got everything kind of going. I'm going to grab a couple clamps from behind me. So I don't think 6 minutes is too long. I don't know about you guys. What are the comments saying? 6 minutes too long to have the first fixture set up? I don't think so. Like I said, the more you fixture, this just comes naturally. You don't really think about it that much. You just kind of do it because you just kind of know what needs to happen. I know how the fence blocks work. I kind of know where I want the endo stops to be. Vice versa, okay? So I'm going to try to position my clamps in a position where I can get into these fillets right here. So I'm going to put the clamps over here on this side, okay? Now I really should be fixturing on the fillets, which means taking my blocks and sandwiching them just like I do here, okay? So that just ensures that this isn't going to bow. But I'm going to actually cheat. I'm going to actually make this tube bow on purpose to show what happens if you accidentally screw up. And we'll fix it on camera because I think there's some great education in screw-ups. You learn more with screw-ups than you actually do by making it right every time, okay? So I'm going to demonstrate a screw-up. So I need to get this tube centered. I'm just going to pull some reference surfaces here, 20 and 18 and 8. This is really going to be important as we move to the final assembly of these. This might come back and bite me, but I think this is going to be the fastest method here. Only because I'm going to be able to isolate the welding problems. 18 and 3/16. Something don't feel right here. 18 and 3/16. Okay, just double check everything. 9 and 1/8. 9 and 1/8. Okay, let's clamp this down. Light pressure. Okay, I'm going to grab some of these side pusher clamps. Right here. Now what these guys do is they have screws going both left and right, and they go in a peg and I can push from the side. Okay, so I want to make sure that I'm pushing right on a fence block, just like that. Doesn't need too much pressure. The more pressure you start clamping on everything, that you can actually roll the tube or cause some distortion that's unnecessary. We're just looking for this to be captured. This is a pretty good fixture because we can fixture, or these are good fixtures because they are like permanent, so they really don't want to move. That guy's locked down, okay? We're going to do the same thing over here. I want to make sure I'm clamping again right over the shims. Okay. And so right now, as this piece is, I got to make sure that this piece is pushed into this block nice and tight, because this is going to set the leg height. Okay. And I think we're okay. We'll just do one more quick measurement, just because. 15 looks pretty good. I'm going to just take a peek down at eye level and make sure everything's touching the shims and nothing's rolled or in a weird position here. This is a little bit strange to me. I'm just double checking everything. This was kind of the beauty of fixture tables. It allows you to kind of just eyeball everything all together. It's a QC and a fixturing speed tool at the same time. Okay, I'm ready to weld. 10 minutes in. I don't think that's too bad to get my first joint done. All right. Now we're going to be wire feeding this just for speed. You could easily TIG weld this if you wanted to. I like to not ground through the fixture table. The fixture table could get some arc that comes up through, and a bad spot will develop on the surface. So you can ground through the clamp or right to the material, whatever is your personal choice. And then I'm going to use this little plate steel, and I'm going to put underneath the weld joint so that the spatter, try to minimize the spatter on the table. Okay, so I'm going to be welding 3 sides and 3 sides only. I don't really need to worry about tacking it because it's pretty tight. I'm just going to go. Okay, so I'm going to weld across the, I want to weld across the top or down the sides. It doesn't really matter, just weld. Okay, ready? Here we go. My welder's not turned on. At least that's not the ground knot on the material. Okay, here we go. Classic noob. Okay, so there's one done. So now what we gotta do, the fixture's already set up, so we're just gonna have to swing in, put new parts in. Come on, there we go. Loosen, loosen, loosen. Now we're gonna leave this rig set up because we're gonna come back and we're gonna use it for quality control. Okay, so that's what we're after.
People are asking if this is pre-recorded.
No, this is not pre-recorded. This is live. If you guys are hearing me, clap, clap, clap. So we're doing this right here in front of you guys. Okay, so I want the weld seam up. No, welcome if you guys are here. We're doing the welder's test right here live on the camera. And I have a timeline going. I'm 13 minutes and 20 seconds into this. Okay. So I'm going to lock this one down. Remember, I have 8 of these to do. Okay, I'm just going to get this guy centered up here because we're floating a little bit. Oh, that's not even tight, you goofball. I hope you tighten your fixtures up, silly. Okay, so 1 1/4, 1 1/4. So we're just doing, I'm just trying to get this centered as best I can. Ooh. 3/16. Trying to float this. This will come back and haunt me when we do the next step if I don't get this kind of right. This is probably the weakest part of this whole fixture, is that my parts are a little bit undersized. But that's okay. Okay. Clamp this nice and tight here. Actually, I'm going to move this over one. Everything okay? Audio's good? Okay. Conrad's giving me the thumbs up. Sorry if I'm talking too much, but this is the boring part. Okay, once again, I'm just going to confirm that I'm sitting on top of the shims all the way around because, like I said, this is quality control. At the same time, we're fabricating, okay? I'm just going to clamp to my clamp. Some people don't like it when I do this, but I have found no problems with doing that, okay? So we're here ready to weld again. Just doing a small downhill, trying to keep the weld to the minimum. Don't need a lot of Don't need a lot of weld for this. And like I said, this will warp, and I'm okay with that. I would pre-bend this typically, but I'm going to show what happens if you screw up and don't account for that. We're going to fix it. So it's going to slow my time down a little bit, but this is a real world condition. Okay. Okay, we're good there. Pull the next one out. What am I into? 16 minutes. Not terrible. I know I think time always goes by way faster than what is perceived. I'm going to start putting these underneath the cart here. I'll come back to them in a few minutes. Okay, so we're going to stick with this one, we're going to stick with this one, and this is just the way fabrication goes. We're just put the hood down, turn your music on, and you're just welding. This is where you make a lot of your money, is just from this repetitious work. Okay. Once again, make sure this tube is pushed up into the stop there. Make sure everything's clamped down. Is there any questions, Conrad, that could be answered of any kind, or one that's coming up more often than others that I can maybe answer as I'm doing this? Nothing really? Everyone's happy. Wow. A happy audience? Happy. You guys are amazing. Okay. Are we learning anything so far in the audience? No one's learning anything? Maybe learning something?
A handful of people want to know what your favorite condiment on a burger is.
Oh, I'm basic. I'm just a bacon, ketchup, cheese guy.
How come you're not cleaning or grinding the steel before welding? Is it already prepared?
So this mill scale on this tube is pretty thin. It is not already prepared. The face of this tube is still raw mill scale. The ends have been prepped. They have been ground and beveled already. I do have a little gap in here, 1/16 of an inch gap, which is going to help me for penetration. But I have the welder cranked up, and we're just burning through it. And this is another way to save money, is just run your welder a little hot. Try to minimize grinding as possible. I'm going to try not to pull the grinder out in this entire video. That will be a great day if that happens. Okay, we're going to keep going. Okay, if I was TIG welding this, I would have to grind the mill scale off, but I'm not. Okay, one more weld. So I'm not too concerned about what the welds look like, even though I'm trying to do my best, but I'm really not worried about them. Oh, look at that. See, I already screwed up. I didn't clamp down. I already got an arc on my beautiful brand new table. That's okay. I'll show you how to fix that later maybe too. That's a good little tiff right there. Well, did that pull up on me? No? Okay. So I'm just continuing to check my work as I go, which is one of the benefits of this, is that I can QC my parts. I think there's a lack of QC in fabrication. All right. Let's see, this goes down, this goes up. Trying to keep my weld seams all in the same spot. It really shows a professional if they kind of keep those in mind. Not every time are you able to do that.
Can you remind the audience what you're building?
Yes, I am building a Fabricator's weld skills test that was developed over 3 videos on YouTube. We're discovering How beneficial is a fixture table compared to not having one? Is there speed? Is there, you're going to suffer some consequences by extra tooling you got to set up? How does accuracy play out in all this? There's a lot of feedback saying you do not need a fixture table to produce accurate parts, and I'm not disagreeing with you. I've just been asking people to show me, and it's been really difficult to get fabricators to show me good quality work without one.
Using a tape measure for reference and using the table to actually measure right now.
Okay, so right now my tubes are cut too short. This tube is cut too short on purpose. I cut it a 1/16 under. So, but this is my stop. This is 20 inches, 20 and a quarter inches between these two. And that's what my outside dimensions are required for my plan. So I'm just eyeballing this tube in between. I'm just grabbing this grind mark here and this grind mark here, and just using it as a reference to get it as centered as possible. I have enough wiggle room to where when I make the base, the big square, that I'll be able to account for that. And if I have to buzz off a little bit on the grinder, I'm okay. But what I'm really after is this tube and this tube to be perpendicular to each other, and these tubes to be coplanar and not twisted. I'm really after this connection and isolating all the problems right here, because this is where all the, this is the booby trap in this whole system. And we need to fix this and keep this right, okay? So right now I'm just pulling a measurement from this stop over to this tube just to get me roughly centered. I don't need to do any layout. I don't want to try to pull my marker out. That's where we're going to slow down. Okay, so now I'm just making sure everything's snug. That's where I want. I can visually see a gap, little gap in between the ends of here, and I know that I'm centered. Like I'm just using my eyeball. Okay. Get everything snugged. Then we do a quick look just to see if there's anything that's glaring wrong. I haven't pulled any of the shims off. They're all in the same spot, and that's the beauty of this, is by elevating the work, all the BBs that are coming off the welder are all spread out on the table. But when I pull the parts out, the tops of those shims are clean. I don't have to clean the table off. I just keep welding. Let the spatter rest on the table. Who cares? Okay, it looks like I'm good. I'm good. I'm good. I'm good. Good, quick visual check. Okay, weld. What are we up to? 23 minutes. Like I said, I'm probably going to take a 20-minute penalty for talking to you guys, but that's okay. I'll handicap myself a little bit here. Okay, so I know when I pull these parts out that they're going to move a little bit, but we'll fix it. And I'll show you that they move when we're done here. Like I said, because not everything's perfect every time. We're going to have mistakes or happy little accidents, whatever you want to call it. We're not perfect, we're human. But the ability to, and how you fix it is where where good fabricators can shine. Okay, I got 4 more to do. So now we're changing tube size. This is now shrunk down in size to a 20-inch instead of a 20 and a quarter. But everything's going to stay the same. I've set myself up for success here with the fixture. I'm going to put everything back in here, just like we are. Okay, I'm going to clamp the tube down. Nothing's going to change. Make sure that's nice and tight. Okay, but what I do need to do is I need to close this gap. See, I got way too big of a gap here. So this is a tooth block, and remember, each of these are on 1/8 of an inch increments. I can jump them over teeth. So I need to move this over 1/8 of an inch, which just means jumping 1 tooth. There, done. There's no measuring involved. I don't need to pull the tape measure out again. That's where I don't like slotted fixtures. Slotted fixtures could be problematic. There. I just closed in 1/4 of an inch. So I'm back to where I was again. That's how simple this system is. One of the things that I'm also proud of is that as a new table company and welding manufacturer, that I'm able to show how the fixtures work. And I think that's lacking in other table manufacturers' areas. They don't have any education on how to use their tools. I pride myself in showing how every tool works and how to get the most out of them. It seems like the other manufacturers will just kind of throw, here's some fixtures, you guys figure out how to use them, right? And that's not right. I'll happily stand up here and show you guys how to use every one of them, and I want you guys to make money. Okay, so I'm just confirming again, this is a little bit slow process. I really don't like the way this is set up, but I think we're okay. A little visual check, clamp, 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 clamp. I got a gap here, that's okay. This is butted up again there. I'm gonna check this again one more time. Yep, we're good. All these little visual checks are just really gonna help me with QC later. Okay, let's weld away. Any more questions, Conrad, as I'm doing this? Oh, my ground. Oh, good job, guys. Of course. I think I'm just going to leave it hooked to that clamp. Actually, let's do one better. No, we need to have it hooked to the clamp because I want to directly go onto the tube steel. That's 2 times. How many times? Start a timer. How many times Jason leaves the ground clamp off? Okay. I know this is the boring part of this type of work. It's this repetitious. When I was younger, I used to kind of really love this because I could just crank the music up and just zone out and think about the weekend and what I was going to be doing and what am I going to barbecue for dinner. Those are all those things when you can just kind of zone out, and the fixturing really kind of allows me to do this. Or in this case, talk to you guys and kind of not really pay attention or just let time fly, you know. Speaking of that, I'm at 30 minutes in. Yikes. That time goes by fast. We're doing good though. I mean, this is the hardest part right here. Okay, okay. Get a little squeeze on here. We know this is where it needs to go. Clamp. Anybody learning anything? I don't know, maybe. I like when you guys ask me questions. Visual check there, little visual check here. I'm just lining up, like I said, this tube where the grind marks are, getting it within a 32nd of an inch, 16th. Doesn't have to be perfect, we'll adjust it later. Okay. Ooh, gotta be careful. Oh, this is a clamp. This is fun. I like sharing my 20 years of experience with you guys. And as a fabricator, I'm always learning something new, and I like learning new things together. So we go developing faster ways to make money in my beloved metalworking trade and fabrication trade. You know, if we stick to the old ways every time without really thinking how we can improve and keep money in our pocket and get to the lake faster, that's my goal for you guys. Okay, I think we're ready to go. One quick visual check, making sure everything's good. I think we got a thumbs up. How's the arc flash in the camera? Is it bugging you guys? Normally I try to block the weld with my hand or my welding hood or an object. You guys aren't getting flash. Okay. All right, we're doing good. I think we got one more. Two more. Two more. Two more. Okay. I want the weld seam to be this way. And then we're missing a tube. I think that's it right there on the bench over there. Audio still coming in good. How's the camera angles? Are you guys okay with the camera angles? If you guys can hear me. You guys can kind of see what I'm up to. But as you can see, I'm not really moving any of the clamps around. They're just kind of in the same spot. I'm just repositioning them to move the part in and out. A little slow, slide this over a little bit. Okay, tight, 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 tight. Down, looks good. Like I said, this is just repetitious stuff. Okay, I got a gap, butt it up there, we go. Like I said, if you're coming in, I know this is gonna bow up. This is gonna be I've booby-trapped myself here on purpose. In the last video, I showed that how you can pre-brand this to maybe eliminate this step. And I think that's being a little optimistic. I don't think most fabricators would catch this. So I'm gonna choose to purposely ignore it. And we're gonna deal with the consequences in a few minutes after I'm done here.
Which tube number are you on right now?
I got one more. So that was 7. So it's tube number 7. So I'm at 33 minutes into this, and I have most of the fabrication done already. So after this next weld, I will have 8 welds left total. Okay, once we build the box. Okay, so interesting information, talking with some of the fabricators, they said they did this in 2 to 3 hours. The pros did, so, or the fab shops that I hired. So I think that's the problem with their work though is that it wasn't right. I was gonna grab my tube here. There's so, and 2.5 hours to make it wrong. I don't know if that's bragging or anything, but I'm open to do it in the same amount of time they did and it will be right the first time. That's kind of my goal. Okay. What do you guys think about this fixture? Is this something pretty simple, pretty easy to grasp? It looks pretty, would you guys fixture it this way? Would you guys have done something different? When you get a kind of an assembly like this, I do like to break it down a little bit. Do smaller sub-assemblies, because this requires less fixtures to do this. So it's a way to kind of stretch your money a little bit. The bigger fixturing projects just require you to have more tooling. So if you kind of isolate it, make your money go a little further. Whew. Okay, go back just a skosh. We're just moving it 30 seconds of an inch back and forth. Like I said, this is probably going to come back and bite me a little bit later, but we'll find out. We're gonna learn together. And this is another thing about fixturing, is that there's so many different ways to do the same thing. Like, we could all have this same plan and we can all fixture it completely different, but have the same outcome. I think that's what's fun about this. No right or wrong way to do it. There might be one better or faster, but... Oh, so here's something interesting. I can see this tube's lifted off my shim, so I need to crank it down more, or something's keeping this from sitting. There it goes. What a great QC check, right? You can see daylight between the shim and the tube. I can still kind of see daylight. So what that would tell me is this tube is going to get twisted on this if I don't fix it. So what's causing that? And I'm just going to get adjust it. Okay, so it's this. I just need a little bit of pressure there. This clamp was kind of rolling it. So this tube must not be square, must be kind of one wall's shaped weird. And when I clamp what this one is, it's rolling it off the shim. Yep, it's still rolling it off the shim. Really, really interesting. Why doesn't it want to sit flat? Let's just move my clamp a little bit. I think that's the best it's going to get, though. There's a little twist in it. I'm going to have to live with it. It's not bad, but I'm aware of that. Okay. Is this tube weird or something? Something's just not jiving here. This is why I like this table. So this is going to slow me down. Something's up with this tube. I guess I'm going to have to be okay with it. Tube steel isn't made perfect. See, this tube doesn't want to sit flat over here either. Okay. Well, that's annoying. But I'm going to have to do with what I got. These are the ingredients that I have to cook with. Okay, here we go. Okay, one more weld and then we get to work about the next step. Okay, like it. That's the last one. So it took me 40 minutes, a little longer than I was hoping. I'm starting to do that in about 30. Okay, as you can see, I have curved this T. There's a curve in it. It's like, oh no! That's one of the beauties of a flat table. You can immediately identify that it's warped. I mean, a straight edge across here is going to yield us. I don't know if you could see this. Maybe, maybe not. Anyway, if you can't see it, there's a good gap in between here and there. Okay, so this leads us to the next problem, and I did this on purpose. I'm purposely leaving this weld off of this side because it's going to get in the way later, and that'll be the very last weld we do. Okay, so now I want to straighten this out. I think the best way to do this after you've caught this problem is that we just take it to the press. And we're just going to put a little bit of down pressure right here, and we're just going to straighten it up. I hope. That's my goal. So let's grab a straight edge, and Conrad's probably going to readjust the camera. But I'm going to come over here to my press. I'm going to see if I can't make it straight again. And I know what you guys are all saying. Ah, Jason, you should have known that you were going to do that. Yeah, I know this was going to happen, but not everything is always going to become in my favor. It's all about how you handle a bad situation. So what I think I'm going to do is put this over here, and I'm just going to put a little pressure there. I'm going to try to straighten it out. Let me get my safety glasses. Okay, so let's see if I can't not make a bigger mess of this as it already is. The glasses are fogging up. I'm just gonna put a little bump in this. Okay, so let me get my straight edge, and I'm just gonna check it while it's in the press. I need to go a little more. I think after this first one, I'll kind of know how much I need to press down on it, and it'll go a little faster, but I'm a little worried I'm going to over press it. And I just barely over pressed it. Just by a skosh though. Okay. Let's see how we did. Good. No more teeter-totter in this one. Let's just move on to the next. This is an operation that I'm, what do I do with that block? Block. Here it is. Are we okay, Conrad? Everybody's good? He's giving me a thumbs up. Can you see me from over there? 3, 4, 5. So one of the things about pre-welding or pre-bending is that you're going to say, Jason, why don't you pre-bend? Oops, I should have left that in there. Oh, should have left that in there. Pre-bending is a science. Depending on how large a weld you put in, are you weaving, what's the welder settings? Are you welding hot, are you welding cold? I guess this might be a good solution just because I can kind of just weld how I want and then fix it afterwards. Oh gosh, I'm nervous to overbend it. Because if I overbend it, then it's going to be hard to fix it. Okay, I like that. 2. If I can get this done in 15 minutes.
Why are you demonstrating this mistake?
Because this is real world mistakes. I think a lot of people are gonna accidentally distort your material. And how do you go about solving it? And do you need to solve it? Can you just ignore it, or should you fix it? And I'm an advocate of just fix it. Unless the tolerance calls out on your drawings they're just super loose, 1/4 inches, but this is, when I watched and see the other fabricators, they ignored this issue and it really caused them to fail. And also, I think fabricators need to have this realistic expectation that you're gonna mess up, right? And distortion is a problem we gotta deal with, and this is just this is the welder's way right here. If you wanna ignore it, it's gonna separate you from the others by paying a closer attention. And the welding table really showed me that these things are bad. Okay. And then what we're going to do is when we're done with these, we'll put them back into that weld fixture and they should fit. So we will use it as QC, which I mean is, am I bending this and those legs are they going, am I staying perpendicular or is that leg moving? We'll test it. We'll put them back into the fixture. So like I said, I've built in a QC device, a part of this. I know everyone's saying, Jason, this is just a stupid box. Or a stupid little thing. Man, if I could nail this the first time, this would go pretty fast. 45 minutes. Just ever so slightly overbent it. Just talking like 5 thousandths. Way better than what it was though. Okay. Any more questions while I'm doing this that I can answer?
Could you set this in a way on the fixture table where you don't have to correct this?
Yes, I've showed that in the video where you could, I could have pre-bent that with, I could have pre-bowed this when I welded it. But that takes a lot of skill and knowing what's going to happen. If this was a reoccurring job, like this was something that was coming in and out of the shop every 6 months, yeah, I could anticipate that I was going to have this problem. But most of the time, these one-off parts are not going to be predictable, and the first time you do this, you're probably going to bend it and go, oh no, I got a problem here. I don't want to cut 2 more tubes. How can I fix it? Oh, dude, nailed that one. Okay. I think nobody really wants to talk about screw-ups. I know I'm not going to get it right every time. I think admitting that you've screwed up and it's all how you handle the problem after the fact. When I was a millwright, one of my I'm not saying my foreman, but my leader when I was an apprentice, he basically told me, he goes, it's not how, a difference between a good millwright and a bad millwright is that the good millwright knows how to cover up his mistakes, right? And so I think there's a lot of truth in that, and I think it's okay to make a mistake. Oh, did I get this one right on the money? Oh, just a little bit. So this is me demonstrating that I made a mistake, and I think adding this mistake into this build really shows that what a realistic time frame to build these should be. Because if I were to just get this right the first time, and people are going to be like, oh, Jason, that's so unrealistic. You just did it right and everything, you have magic hands. So I overbent this one a skosh. Oh, I remember talking like 5 thousandths, but I think we'll be within spec. One more, oh, 2 more. Okay, oh, we're doing good. I mean, we got an hour into this so far. Hour and 20 minutes if we want to include my cut time. And we're adding a mistake into this. So I think we're doing good on time here. Okay. Dude, I'm getting better at this as time goes on. Get a little faster, I could count how many cycles on the pump. Okay, I'm gonna pull this last one out. And then fix this one. Now just a reminder, if you're coming in, I accidentally, purposefully warped these tubes. The fillet welds that I put right in here have bowed these 2 sides up, making this T not a T, it's a curved T with a perpendicular tube in it. Last one, confirm how bad it is. Yikes, that's horrible. I mean, that is bad. That is really warped. Okay, this is the last one. Can I hit it? One more. Please don't have overbent that. Not on the, oops, not on the last one. Nailed it. Nailed it. Okay. All right. We got all our pieces. They sit. Man, there's no teeter-totter in those. They're all straight. Now the question is it still straight? Like, what I mean by that is this piece still perpendicular to this tube? And like I said before, this is why I love these tables. I can put this back into the fixture. Okay, and it should align itself up. Which means is this stop, and these stops, this should just drop in. If I did this right. If it doesn't, oops, that's why. Get that out of the way. I was like, what's going on? Okay. But you look at that. It goes back into the hole. It's touching here, here. Yes, success. Okay, so this tube and this tube are perpendicular to each other still. When I put it in the press, it didn't cock to the left and it didn't cock to the right. It just straightened this out. Do another one just to confirm. Oops, this one's the long one. But we can get another one. I think if I just check a couple of them, I'll be okay. I'll know that it. Oh, that one dropped in. Beautiful, absolutely beautiful. We did it, success, we fixed it. We fixed the problem. That actually worked out better than I thought, to believe it or not. I thought we were gonna have some issues there. Okay, we're good. Let's just line them all up. Should we just do another little visual inspection? I got a little time. Woo! Line up all the, this is just kind of fun. I'm not really, boy, those are pretty straight. This one is this one might be a little wonky. Uh-oh. This one might be a little wonky. Let's put it back in. Let's put it back in. This one might be bad. We're gonna check it though, right? Nope. Good. It's just an optical illusion. Must be some grit or something on the table there. The fixture don't lie. Okay. Let's break the fixture down and then we'll set up for our final assembly. And we should be done here in a half hour. That's my goal. Okay. So let's take everything down. So this is the other thing. What do you do with all your fixtures? If I know I'm going to use them again, parts, I'll just kind of throw them on the floor, because just keep them within arm's reach. I don't think I'm going to be using these anymore. So I will put them away. This is all part of the plan here. The time to set up the fixtures needs to be accounted for, so this is why we're doing it live. Don't need these. And then, as I'm doing this, any more questions I can answer?
Can you remind new viewers what you're doing?
Yes. So this is kind of a long story, but I am trying to recreate a Fabricator's skill test that the forum and I developed this summer. And we're kind of testing the theory, do you need a fixture table? Is it necessary? Is it slowing you down? Is it providing any relevance to your business or company? Do you need this as a beginner? Can a professional benefit from this? I've already hired 6 individual fab shops to build me simple shapes. to regular tolerances, and none of them have been able to achieve those. So what I'm doing is I'm recreating the same test on the fixture table to see what the results are, and then we're going from here. So, and I can tell you what, the fixture table really allows me to see my mess ups. I am not perfect. I can admit when I'm wrong. When I was younger, I thought I was the king, man. I thought I couldn't do no wrong. Thought I was really good. I'm not saying I wasn't, but it wasn't until I got my first fixture table that I knew, wow, would I have let that go? Would I have missed that before? Wow, this table's making me look really good. Like, I thought I was good, but now I'm really good. And that's why I shared in this excitement with you, because it's like, man, this table and these fixtures just give me superpowers that I've just never had before. Okay, all right, so we got everything broken down, only took a few seconds. Now the goal of this is now I have 4 pieces, and I want to recreate a box that looks like this. Okay, I don't know if these are the right parts or not, but that's what I'm trying to recreate. Okay, so what I have to do is I noticed on some of those tables, the ones that the other fab shops gave me, the legs are like this. The frames are not square. The tubes are rolled inside of each other. The frames are twisted. There's just a lot happening here. So we need to set up a fixture that's going to align the legs in the right location. Right now, if I were to butt these 2 tubes together, I guarantee this tube is not correct. So we're going to use this tube to get the correct alignment from this surface. So here we're going to set up a fixture that's going to give me the outside square and then put this leg where it needs to be. And the only control that I'm going to have are the joints. I might have to sand the joints a little bit, might have to weld a gap. We're gonna work on the joint, but the fixture is going to locate all the parts for me. So we need to be able to do that. So the fastest way to set up fixtures, especially when you got these large surfaces and some tall legs that we're going to elevate off the table a little bit, is these guys right here. These are the tower blocks. And I think the fastest way to come up with our box is just to put these around in a box. Right. Something like this.
Inside welds for bending the square tube.
Inside weld? What do you mean by inside weld? This weld?
Yes.
So this weld I'm purposely leaving out because I'm going to need it to measure perpendicularity. We'll come back and weld this one later. It's not a weld that's really going to change the structure. It's not going to warp it because of where it's at. And I'm going to need it so I can push my material flat up against the fixture. So I don't want to have to grind anything. Remove the grinder from the equation at all possible. We'll come back and weld this one later when I'm all done. That'll be the very last weld. I have to do the bottom of this anyway, so I got to weld this and that, and we'll do those at the same time. Okay. It's just a little bit of forethought and thinking about this. Oh man, it looks so good. It looks really straight. Because that's the thing, how are you going to get these straight when you're doing it vertical? It's a really hard thing to judge. Okay, we're just going to keep going here where I'm at. 1 hour. 1 hour into this, and this should go pretty fast here. Let's just throw these fixtures up here on the table. Okay, so what do I want to do? Let's start putting some pegs in here, giving ourselves a 90-degree corner. And we can so remember, I'm making a square that's 20 inches wide by 20 1/4 inches long. So all I got to do is I'm just going to butt these up against inside here into these stops. This is how fast it is. And the pins just kind of lock everything in. I'm just going to put the pins into the slots and get all slotted out so it won't move forward, back, side to side. Okay. We're just going to lock it down with the screwdriver. Give ourselves some fixed points here. Same with this one. This looks pretty close. If I have to come back and move them again left or right a little bit, it's generally not an issue. It's just real easy just to, you don't have to, I guess you heard what I'm trying to say, when you're fixturing, just start going. If you need to adjust something, it's okay. We might have to move some of these around a little bit, but this is kind of what's going on in my head. And the more you do this type fixturing, you'll automatically build this in your mind. It's kind of like driving a manual transmission when you're first beginning. You're kind of like, oh, I got to shift and push the clutch in, and then I got to watch for traffic. I got to put my turn signal on. How am I going to do that? And before you know it, you're doing all of that simultaneously, and you're singing to your favorite song in the pickup truck, right? You're not paying attention to how to shift gears. So this is kind of the same thing as fixturing. You get better at it when you practice. All right, so we got these two are fixed. Now let's start pulling our dimensions. So like I said, I'm just using the tape measure for reference. I want to be at 20 inches. So I'm going to push that back to 20 inches just so I know where the right hole is. Just give me, so I'm there. I'm going to line it up with this one. Not going to make this overly complicated. It does take a little bit of time to do this, but drop these pins in the hole. Now what I don't like is this hanging off the back. The table's just a little bit short, so what I'm going to do is I'm going to put another block right here on the side to extend this surface off just a little bit. I probably don't need to do that, but we'll just do it anyway. Yeah, this is probably not needed, but so one of the things with this table is having this big thick side here. Allows you kind of to expand it. Okay. I love that. Okay, I don't probably need this here, but I'm going to use it anyway. There, now the fixture's hanging off. Now, the one thing I don't like about slots is that they're able to slide backwards. So since these are fixed, this one's also fixed. Do I need to put a black stop behind there? Maybe. We'll see. All right. I guess this is going to be slotted. This one needs to be 20 1/4, so it's not going to bottom out in the slots with the bolt. So 20 1/4. What I mean by that is that's where this one needs to sit. And this pin and this slot are not up against each other. So the potential for this to slide is great. So what I'm going to do is I'm going to back it up with a fence block. The fence blocks are fixed fixtures. They have solid pins. They cannot move, slide or back, or they cannot move back and forth. So so there we go. I'm going to put one here and I'm going to put one here. Now what that does is now I got a 1/4 inch difference between the two, right? So I'm just going to grab a 1/4 inch shim. And I'm going to put in between the block and the tower block there. Just like that. This also aligns it, keeps it straight. And then when I go to push on it with the pushers, it can't slide backwards. Okay, so I'm just going to put a little constant pressure back. So these are just things, like I said, I've learned over time what to do, where have I screwed up before, and I've had fixtures slide on me in slots. So that's why I'm really not a big advocate for slots. They are necessary here and there, but try to avoid them. All right, so that's set at 20 1/4, 20 1/4. This one's set at 20, and this one is set at 20, but what I'm thinking I want to do is, I think I want to back this one up too while we're at it, because I'm not a real big fan of slots. So this will work. Actually, putting this here is going to work out good in my favor. Actually, 20. I mean, when it says 20, like it is 20. It's not like it's a little bit off left. It's not a little bit past the line, not a little bit before. It is 20 inches. Like it is dead on. I'm not going to trust the tape measure. I'm going to trust the fixtures. Anyway, tape measure is just confirmation again. Okay. Any more questions? No. But I did notice, I'm going to take this off. I got a little bit of time. Remember my ground fell off? And I think I arced the table right underneath this fixture. Nope, I didn't. Okay. I was a little worried that I arced the table where the fixture was going to sit. Just wanted to confirm that that was okay. Oh, come on. No more questions? Everybody's happy?
Dave is asking, what about offsetting your pins in the fixture setup?
Offsetting my pins. What do you mean by offsetting my pins? Can you clarify for me?
I'll ask him to clarify.
So, okay, so we're almost done. Okay, we got the box made. What we're doing here is we're creating our fabricating fixture, which means we're going to use this to build off of, but we're also going to be using this for quality control, which means when I'm done, I should be able to take my fixture and put it back into here, and I'm going to be able to check it. I think that's really important. And then knowing that these are dead nuts and square, you can take any square you want, and we can check, right? Probably can't see this on camera. I probably should grab the big square. Should I grab the big square? I'm gonna give myself 2 minutes to prove to you. I know, like I said, I'm handicapping myself by walking through this process. So this is a lot of you guys probably don't believe me how square this is. This is a machinist square. Okay, so I'm gonna put this up against here and here, and it is, I mean, we're talking maybe two thousandths out, maybe. I mean, that's really good. It's two to 3 thousandths out in 24 inches. I mean, that's dead on. That's incredible. Okay. And like I said, I don't need to prove this to you. Once you start using this table a lot, you're just going to trust it. All right. Ta-da! Now, let's get all our pieces where they need to go here. And I will show you what we need to do. Okay, 20 1/4. We're going to do the same thing we did before. We're going to put shims down and make sure there's nothing down on the table. Like I said, you're going to see a lot of the same repeat stuff over and over and over again. This is back to driving a manual transmission. You're not going to think about it once you start doing this a lot. You're just going to grab the shims and go. You're going to put the parts down. You're not going to think about it. Okay, and like I said, I have them perpendicular because this is going to control the roll of the tube, which means these shims are what these surfaces are going to rest on. So you don't want them like this. You don't want them turned 90 degrees because, like I said, you're trying to bridge. You want this to go from edge to edge. So if this is a wider piece, you might need to stack 2 of them here. Okay. Okay, so this is one piece. This is 2 pieces. This is 3 pieces. Which one is this one? This one goes here. And it's a shorty. Boom. Did I get this right? I think I did. Something ain't right here, maybe. What's going on? Let's make sure 20. Yep. 20 1/4. I think we're okay. This slides over. This slides over. That piece is cut a little short. Okay, that's kind of the way it goes. I don't really like this one. All right, so now as you can see, I don't know where this goes. Left, right, forward, backwards. I don't want to use the joints to line these things up because that's bad. So I want to locate this leg, and the way I'm going to do it is use these holes. Okay, so let's see here. Let's grab a couple more fixtures here. Okay, so a good way to locate where this goes is I need to be, in this instance, 9 inches from here to this surface. Okay, so I'm going to set up a block that's going to put me at 9 inches. Right? Now, one of the things that when you hang these fence blocks on this fixture, they might want to sag or fall out. So what I like to do is I like to take just a regular bolt. Where's my bolts? I had a whole bunch of bolts. How am I doing for time? I need to go faster. Ah! Bolts. Normally I keep them right here. Here they are. Okay, so I'm going to thread up just a regular bolt because these are tapped holes right into the back of this. And this just keeps this fixture from falling out. So now all you need to do is add a shim right here. Right? And now I can push this tube up into it, and now that tube is perfect. Now whatever this joint is it is what it is. I can't change it. If I was having interference here, I could sand it, but this gap is the way it is. This gap is the gap. Okay, so let's just keep going around. And we're just gonna do the same thing on this side because it's a mirror image of each other. We're almost ready to weld. Almost there. What time is it? I'm doing good. I'm doing too much talking though. My mouth's getting dry. I'm gonna have to take a water break here. Okay, so this one needs to be. This one's a little different because it's going to be 9 1/8 from this surface to this surface. Okay, so we need to look at that, but something doesn't look right here. So I need a 5/8 shim instead of a 1/2 inch, and I'm going to use, whoopsies, I'm going to use this box right here, and it should have my 5/8. This is the beauty of having the right tools. You're not running around looking for components or pieces. So I need 5/8 to slip inside here. All right, just like that. This has me a little worried because that's a huge gap over there. What did I do wrong? Let's figure it out. Oh, that's not right. This goes over here. Sorry. What you got? Oh, water. Thank you, Conrad. So I need to be 9 1/8. Where am I at here? Oh, so I need 3/8 of an inch. What am I doing 5/8? Okay, 3/8 of an inch. go. Ta-da-da-da. Now we're locating. I got one more block to do, then we're clamping, and then we're welding. Like we are on our way. We're gonna have this finished up here. So hopefully you guys are not bored out of your mind watching me do this. Nobody wants to watch somebody work. Okay, so that's pulled up nice and tight just with my fingers. Put that back in the box. 3/8 of an inch, boom, right there. Make sure that touches, this touches. So what it's gonna do is I need to make sure that this tube touches this block before this corner does. And it does. Okay, need one more 1/2 inch shim and we're clamping and we're welding.
Audience wants to see you double check by pulling the tape measure.
Tape measure from where? From
the lengths are all correct. All the way
tape measure correct. 20 1/4. Okay, can you guys see that? Let me turn it around this way. 20 1/4, maybe you can read it. 20. Okay. Okay, everything's good. Looks like I'm gonna have some gaps to fill, boys. That's all right. Like I said, I tried to, this joint is a little wonky over here. What's happened here? This is why I like this fixture. It really allows me to see where I screwed up and we fix it. Whoopsies. So let's take a look at this. I got a funky little connection over here. So what happened? What has happened? This tube too long? This entire tube too long? Definitely is. So let's pull it out and let's replace it and we'll see what happens. I think this tube is, there's something wrong with it. We're gonna come back to it though. We'll save it for the next, either that. Let's see how this one fits. Okay, so this is also, what am I doing? This is the wrong one. No wonder why it's not too long. I put it in the wrong spot. Goofball. You got these backwards. I did it wrong, guys. Too busy talking. What the heck are you doing? Ding-a-ling. Got my material mixed up. Okay. I have these tubes labeled, but I welded over my tag. Classic rookie move. That's much better. Look at that. When you put the tubes in the right place. Let me take this out. We're killing it on time. We're going to be done here in about 15 minutes. We're blazing through this. Even me yakking on the camera. That's so much better when you get the tubes in the right spot. But we have an issue. This is a good issue. This is great. So this tube does not fit, which means I got this joint a little bit too tight. So I'm going to take this to the belt grinder and I'm going to open it up just a skosh because this block won't go in. I'm interfering with this intersection. So let's just give myself a little clearance. Right back. I'm just going to open this up on the grinder here. Should only take a second. Come on, sander. Okay, so the fixture told me that my tube was just a little long. So I just buzzed a little bit off. And now we got a good fit. Okay, so if I would have ignored that, that would have caused my dimensions to be out. Now I got some clearance. See, now I'm up against my stop. I got just a skosh room there. This one I'm gonna have a gap. I got a gappy gap to fill. Oh no, this is the wrong tube also. That's why. We're all good? Everybody's happy? Let's see if I can. That's the right one. Let's see how this fits. Yep. Oh, when you get the right tubes in the right place. Beautiful. We're ready to put some clamps on it. So what's happening is this block has a nice tall surface, and when I press it up against it, it's going to square everything up. Okay, I'm going to push it up against this block. It's going to hold. I can do that with this. So if I want to, I can put this in here, this hole. Okay, so now this block holds this up against that surface. This is why I really like these big tower blocks. It's kind of like having a table. And then two, I can push top and bottom because these are crossed, so I can see I can push down and over at the same time. They're super slick. If you don't have any of these, pick yourself up a few. See how I want to do this, like that, like this, there you go. So this allows me to push down and over at the same time. Just like that. So I want to make sure that these tubes are staying up against there. I don't want to put a lot of pressure on it. Down there, down there. Great. And then once I get all these fixtures in place, the next one is going to be a breeze. We're going to be set up in a matter of minutes. How am I doing, Connor? You think I'm going to make the 2 hours?
I think you'll be close.
That's with what? I got, how much more time do I got? I got, if I want to add my 20 minutes back in, if I want to get under the 2 hour mark, how fast do I got to get this done?
17 minutes.
I got 17 minutes. Okay. Sorry, men, I'm going to slow the talking down a little bit. I'm just going to go here. 17 minutes. I think I can do it. I think I can have these welded out in that time. Like I said, it's a 2 hour is just a little goal I set for myself. But in all reality, I need these parts to be right. That's the most important. So if I go over by a few minutes, I will gladly accept defeat of my personal goal. Hold that down. I need to push backwards. So I need to, I think we're just going to clamp it back to itself like this.
Audience is asking a question. Why are there two different lengths for the sides, 20 1/4 versus 20?
It was just the original from the very first video is what the dimensions were. It's just a random number. I do think it's kind of interesting because it allows, as an experiment or a test, you're not able to set up two fixtures the same. You're not set up the saw. How would I explain this? Whatever you're choosing to do, you can't just set up one fixture and make all 8 corners. You're going to have to make some adjustments. So that's typically reality. You're rarely building something that's a perfect box, like a perfect symmetrical box. It's very uncommon. So I think this, having one side that's a little bit different, just throws a little wrench in the gears. Okay. but it really stemmed from the original video. Or me building the very first, of me building the very first box. Boy, I'm really boxing myself in here, aren't I? This one's going to be tricky to get in there and weld. Ah, goodness. How am I going to do this? How am I going to do this? This is my best bet. Okay. So I think this is where, if you have a regular plate steel table, I'm not saying that you can't do things accurately, but what I think actually happens is that you know that your table is bowed or warped. You know you're going to have to weld clamps, stops to your table. You know you're going to have to shim your work up to get it flat and level, right? But what actually happens in reality is you don't do any of it. And that's where the problems happen. And because you're going to be doing it over and over and over again, you might skip a couple steps because it's not easy. And when something's not easy, you're going to choose to skip it. But because it's so easy to put 3 or 4 clamps around this, I'm going to do it. I'm going to over clamp it. I'm going to constrain it more than what it needs to be because it's easy to do so. And I'm totally cool with that. I'm cool with over constraining this. I don't want to do this twice. All right, so I'm going to put more clamps on than I think is necessary. More questions? No more questions? Okay. Like I said, it just looks like this is excessive for a box. Well, this is where mistakes happen, is when you don't put enough clamps on. I've learned throughout my career that there's no such thing as too much clamps.
Just when the people started talking about the clamps.
Was I right on that one?
Yeah.
Well, you have to remember, so I have to constrain this box. I can't have it lift up. I can't have it pull out. I need to push it over to the side. So how many clamps? This is a long tube. If you just put one clamp on one side, it might cock. So you gotta have a clamp on the other side. This is where I always tell everybody, get at least 20 or 30 clamps when you buy a fixture table. You will use every one of them and wish you could have still bought more. Because remember, these are all individual pieces. So how are you gonna, what's gonna hold them? And because I have so many clamps on here, I can weld this all out without having to worry about weld sequencing so much. Okay, so I think I've got 2 more clamps to put in here, and then we're good to weld. And then we're gonna cross our fingers that we did a good job. Okay. All right, so let's pull some measurements while we got it. So outside to outside is supposed to be 20 1/4. Now, I don't know if you guys can see that or not, but this tape measure is a little wonky. 18 1/4 down to the 64th or so. Even way up here. That is exactly 20 inches. Can you guys see that up there? At the top of this leg to here's 20 inches. Will it stay? We don't know. But as of right now, it's where I want it. Well within a 1/16 of an inch. Let's get a little pop just to make sure. There we go. Clamp. Make sure everything's tight. I didn't put a clamp right there. Hold that back. double check. Jeez, this is so good. I almost want to pull the caliper out, but I'm not. Okay, so one last check. I want to make sure I'm sitting down on all the shims. I can just put my finger underneath here and I can try to pull them out. If they wiggle, that means there's air underneath of them and we got issues. Okay, I don't know what to say. I think I'm ready to go. Exactly 15.5 inches off the table. Everything's sweet. Let's weld one and see what happens. Don't forget the ground, you noob. Like you haven't been doing this for 23 years now already. Okay, so the weld sequence I'm going to do is I'm going to just weld the outside corner down. Okay. I really don't have to skip around, but we're doing this alive. I can't screw up. All right, so the next one I'm going to do is I'm going to just weld across the top. Okay, might as well do the fillet. Not happy with my fillet size there. I kind of want a little big. Fillet's where we're going to add some major issues. Now when you're welding, you want to go inside corner to outside corner. I got a little gap here. So pulse the gun just for a second. Okay. I'm going to try to keep this fillet weld to a minimum. Keep it small and tight. I don't want to put a big fat weave in there. It's very crazy. It takes 10-15 minutes to set it up, but only 3 or 4 minutes to weld it out. Okay, one more, and then we're pulling it out. I would consider this a success so far. I haven't had to pull out the grinder. I had to make one adjustment, but nothing major. Okay, there we go. One done, except for the 2 welds we missed on the other side, which we'll get in a minute. Okay, so start pulling clamps off. Any questions as I'm doing this? Nope, no questions? Okay. That means I'm doing good answering them then. Okay, so little concerning. I could see that this tube pulled off this fixture. I mean, I would probably guess 10/1000ths of an inch. So it needs to tell me is I need to push back here a little bit more on the ends, not in the center. This is where we're back to QCing at the same time as building. I'm looking for anything that could be wrong or pulled as this is cooling off. So QCing at the same time. Okay, this next one should go really fast because I know what I'm doing now. First one's always slow. Ooh, there's some pressure on that. But as I release it, stayed. This is going to be really interesting to see what it does after I pull this out. So I do have, like I said, I have some tolerance. It don't have to be perfect. But here's my motto and something my sister always tells me. I don't have to be perfect. I just have to be excellent. And that's kind of something that I've been really adopting. I don't have to be perfect all the time. I'm just striving for excellence. And if I go for perfect, it just makes you frustrated. So just be excellent. This table really does make me feel like a super fabricator. Okay, wow, everything's, I see I can pull it off just a skosh, but it's straight. Like everything's just kind of shrunk just a little bit in. Just a little shrinkage from welding. We can check that. Okay, so it's sitting here neutral. Got all our fixtures here. We're going to put them back in the same spot here in a minute. Okay, let's just do a little. Okay, so I got a little bit of movement side to side, maybe 10/1000ths. How do we do for a leg twist? Okay, so we're a little bit out. So what I noticed is the legs have moved in just a skosh. Okay. So they've moved in 1/16 of an inch. It's at my parameter, but I really don't like that. It's about the same that it moved here. That's interesting. Did I not get one up against the back? Or did we just literally shrink? Let's check for flatness. Oh, I gotta pull this off. Pretty flat. So now I'm at a crossroads. Do I fix it? Do I try to push back a little bit with a clamp? Do I worry about that in the next step? Technically, I'm within tolerance, but like I said, I'm going for excellence here. What I think will probably happen is when I weld these seams right here, it's probably going to pull back into spec. But man, everything's looking pretty sweet. Should we try it before we move on? See if I can make an adjustment. Let's do that. So I still have these to weld, and I still have the bottoms to weld. So let's weld these out and see where it takes us. Thing is, when I put this back, when I do this, I won't be able to put it back in the fixture unless I grind it off. So let's just go for it. Oh, we're gonna weld those ones flat. Oh. Well, like I said before, it's okay if things move on you. This is welding. It's all about how you handle it. Like I said, how do you hide the mistake? How do you fix it? You ignore it? Are you aware of it? And the answer is I'm aware of it. And I'm gonna have to fix it, right? One way or another. You either cut it apart, do it again, push it, pull it, bend it.
Your ground?
Oh, ground, yes. Is that the audience or Conrad?
That was me.
Okay.
It just fell.
Okay. So what we can do is we can flip this over, and we can put it right on the table. Right, get this in the right slot, and then go this way. Oh, what a great way to check. Look at that. Woo, that pulled that right back where it needed to go. Man, that is good. Dude, like, am I really happy? I am really happy. Look at this. Not even teeter-tottering on 4 legs. Okay. Straight. Let's weld these out. Oh, dumb ground. What a noob. Golly. Where am I going to hook this to? The second one I promise will go faster. We're kind of just going through this together. You know, every job's going to be a little different one. But it's like, do you have the tools available to you to tackle anything that comes into your workshop? I think the fixture table allows me to problem solve pretty fast. Ooh, little gap here. We'll pulse the gun for a second. Oop. Okay. I want to have a little gap. Okay, how the legs stay? So they're still in my fixture. Man, that's so good. The QC check. Oh, that's so nice. It's heavy. Oh, it did move a little bit. It did move a little bit, but it is so close. I'll let it cool down, see what it did. Woo! I mean, can you see that, guys? I don't know if you can see this. We are nailing it. We'll check perpendicular and everything a little later, but let's move on to the next one. Let's let this cool down.
Broke 2 hours.
Did we just break 2 hours? Aye. Okay. Like I said, I'm doing too much talking. If I'm under 3, I will happily accept that. This one, I'm almost done. This one's going to go faster. I'm going to fly through it. 2 identical parts. That is the goal. Something wrong here. Something wrong here. That's this one. $19. Right. What do I got going on here? There we go. I think one of these is just a little long again. Yeah, one of them is just a little long. Which one is it though? This one or this one? No. Well, like I said, I did have to fix myself. I think this one's just a skosh long. Somebody hit it on the belt sander. Okay, so this tube I just had it was a little long. Okay, I think everything else, this one might be just a skosh long too. All right. Looks good. Let's put our fixtures back on. Let's locate it side to side. Let's get this sucker welded out. Move on to the next job. More questions? More answers? No? Did we ever get a response back? With needing to answer any more questions?
People are just generally curious about the cost of the setup, the table, the fixtures that are needed to build this, or what sort of things they should be looking for in
Like I said before, just get started with a fixture table system, which means start small, get a dragon wagon, and then when it comes to fixtures, you can start with a small package that we sell, or you can see what I'm using here. But the packages are probably going to get you in the ballpark. Gosh dang it! I think I'm going to need to shorten this one too. And then you can kind of see what I'm using. Towers. You could probably get away with not running towers right away. This one's also just a skosh long. Come on. So as you can see what I'm doing, it's like the table's not allowing me to screw up. It's saying how your parts are too long, your parts are too short. It's QCing me as I go. Like it's saying, see, I can't put this block in. It will not go in, which means that this is over here, something is wrong. Right, so I need to shorten this up a little bit, or this one looks like it's too long to me, actually. Oh, there we go. There we go. Maybe that was just not need to move over. No, it is too long still. So I think both these are just a little long. Excuse me. Monsters. I'm gonna let that run for a second. Oh, let's think this one goes. This is not the right one. Oh, you know what? That was probably right. Look, I had the wrong spacer in there. The wrong spacer in here. Whoopsies. There we go. There we go. That would help if you did it right, you goofball. I know, sometimes you just laugh at yourself because it's like, I'll go here. Okay, we're good to go. Let's just put all the clamps on and we're welding. Wow, I can see that there's like I said, this gap in here. Not really liking that. What is causing this? Yeah, this is a real visual. This is really visual. And I really like that. Like, it's really fast to identify problems. Because I can see the entire picture, right? Can you imagine you watch a like when we watch an edit of our videos, we can see the whole, I can see the whole picture. And then I can say, oh, we need to make some changes. When you're able to see the project in its entirety, like I can in the fixture, I can see all the parts and how they're all lined up to each other. I can instantly spot things that are wrong. But if you're working on one corner at a time, it's, you know, I can't see what this corner and this corner and this corner is doing. So I'm going to change it up. I'm going to put fixtures back, holding it back, because I noticed that it was kind of pulling out a little bit. So we're going to make some adjustments to this. What does this whole setup cost? I mean, with the table and the legs, you're looking at right around $3,000 or so, and then fixtures, well, that's kind of up to you. But generally, you're going to end up realistically with about the same amount of money in fixtures as you do table. So I'm not going to try to sugarcoat it or try to say you can do this cheaper. It's just what ends up happening over time. You can either choose to purchase it purchase all those fixtures right away and get to work, or you can do it over a course of a long period of time, or as the job comes through. Okay.
Question.
Yep.
When it comes to offsetting the pins in the fixture towers, is it to prevent slip?
These pins right here, yes. Yeah, so there's a little bit of slop in the slots. We're talking a couple thousandths of an inch, so I don't want them to push back or move, so I back them up if I'm in the middle of a slot. But if I'm slotted out, I'm okay. Pins are gonna keep it from moving. But when I'm in the middle of a slot, this pin, and like I said, I'm pushing back with this clamp backwards, I will move this fixture. This has enough power to push the block back without me knowing it. So that's why I've backed these up with these blocks. You can see these pins are tight now, except for that one. So I can push hard with the screw. Boy, that one, I got a big gap to fill over here. Woo! That's okay. We got the wire feed. We'll fill her up. You'll never know. All right, let's keep going. I'm just yapping here. I'm going slower than what I want, but I don't have a lot of room for another fixture in here, so we're just gonna have to use some clamps, some other clamps to hold it back. Which way is what? This way. Really? This only goes one way? This one's wrong. This one's wrong. How did I hold this back last time? It's like this. I mean, I know it seems like this is not worth it. And this is, all this extra work is just welded together. Better do it right the first time. That's what my mom always said. So. It is funny. It takes all this extra time to hold it all in position, and it's just literally 3 or 4 minutes to weld it out. It always surprises me. Okay, I'll hold it down. Just a few clamps here. It seemed to work pretty good last time, what we did, so we'll just keep it going. All the clamps. There's something kind of fun about this. It's kind of like playing with Legos too, if you guys like Legos or Tinker Toys. Okay, 2 more clamps. I think we can turn and burn on this. But that's not a lot of room in there. Let's make an adjustment here. There we go. I lied. 2 more clamps. Okay. Okay. So I got a little soft mallet here. I noticed last time maybe it wasn't quite up against the block. I'm just kind of giving a little bop, 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 bop. See, like that one moved just a skosh. That one moved a skosh. Double check everything. Dang, right on. So this one's a little bit, when I mean a little bit, we're talking 10 thousandths. Okay. I know, I'm freaking out. Just double checking, I just don't really want to have to pull the grinder out. The double grinder. What? So this is something strange here. No, it's okay. Okay, looks like it moved just a little bit. All right, enough worrying about it. Let's go. Make sure everything's down. I'm just gonna give everything one last wiggle. Check my shims. Okay. Got a couple big gaps to fill. We got this. I'm just gonna stay in one corner this time. I think this one I'm gonna have to pulse. Definitely gonna get full penetration on this one. Ta-da! Okay. Big gap successfully filled. Okay. Leaving the fillets for last. We can talk about fillets here in a minute. Another good sized gap. I mean, nothing crazy, but it's a little bit more open than I like. Okay. Probably didn't have to sand those back. Another gap. It's a little bit larger than what I want. It happens. Deal with it. Okay. Now for the dreaded fillet. So what happens with the fillets? We're gonna turn a square box into the sides are gonna end up going like this. They're gonna bow inwards. And we'll be able to see that with the straight edge. So each side is gonna have a concave when we put the straight edge on it. So I'm gonna try to keep the fillets as small as possible. I don't want to do any weaving. I don't want to do anything that's going to add more stress into it. So nice and small as possible. If I didn't have to weld this joint, I wouldn't. Fillets are the worst. They will literally destroy a weldment so fast. They are very destructive. There's so much power. That cold weld has when it cools. Just trying to minimize that fillet there. Trying to go fast, trying to keep it small and tight, no weaving. Oh, fixture's in the way. I think we're okay. Whew. Okay, done. Well, we flip it out and we take a peek. And when we QC it, and then we'll make any adjustments necessary to make it fall back into tolerance. I'm not gonna, like I said, I'm not gonna say that we got it right off the bat, but it's not gonna leave here wrong, especially if I know about it, and this fixture is gonna tell me that if it's right or wrong.
Are you using the CMM to check, or?
So unfortunately, the CMM is being used at the moment. But I know a lot of you guys do not have a CMM machine to check your work. So I think this is a great opportunity to share how we can QC your parts without something like that. And because we've built using a fixture, we'll just use the fixture table to quality control. And I might pull the calipers out. It's not necessary because the table is going to kind of do that, but once I get it all out of here, we'll stop the time, and then we'll look at QC, right? So that I can talk more about it. If I wasn't on camera live, I would just do it really fast, but I want to chit-chat some more about it. And just like that, just takes a few seconds to weld out. And then more time to hold it in place. This reminds me of painting a car. If you've ever painted a car or see somebody paint a car, they'll have weeks and weeks or days and days in prep work, sanding and buffing and bondoing, and then it's literally 2 hours to paint the car. You know, and this is kind of in that same world for me. It's like you have all this time setting up the fixtures, getting it dialed in, and then the welding is really a small piece of the puzzle. And it goes really fast. But more than anything, I'd rather take a little extra time and not have to redo it. Okay, so let's just taking all the fixtures out so it's loose. And it shrunk about the same as the other one, just 0.010 of an inch, maybe, just a little shrinkage. But I can confirm, just by being in this fixture, that it's not over tolerance or just a little bit under the center line of my parameters. Okay, so let's flip it over. Okay, and check here, check the tips of the legs. Same. I think this is great. Let's weld the sides here, and get it all finished welded, and then we'll compare everything. All right. So these are the welds that I missed in Operation 1 that I didn't weld because they would have interfered with my secondary fixture. So we're just picking them up right now. And I'm not worried about really too much weld distortion with them because we're pretty much welded out. So it shouldn't move too much, if at all. And if anything, I might actually move it in the right direction. But I do have it back in the fixture, so if it doesn't want to pull, it does have some backstops. So let's weld the tops of these back to I got a little bigger gap than what I want. So it's a big gap. Let me push. Hey, gaps happen. I need a t-shirt that says that or something. Sort of. Problem with gaps are, and I try to avoid them, is that they just take too long to fix. It's not that it's the end of the world, it's just time wasted that. And if you're new to welding or fabricating, you can cool the weld down by increasing your stick out a little bit. I should just put the welder down a few amps. We're back to doing it the lazy way. Remember how we talked earlier in the podcast about us being lazy, not doing it the right way? Okay, I just turned the welder down a few amps, fill these gaps up. That one didn't have a gap, but there we go, this one's got a gap. We're almost done. Oof. Come on. Almost done. Stop the time here once we're... Goodness. I'm sure some of you guys are watching and going, yeah, I know, I gotta fill that gap. They're probably laughing at me. Okay, she's welded out. Now, the plans say that these need to be buffed smooth. I mean, my eyeball is pretty good at telling me if there's something flat or not. And that looks pretty dang good. Okay. How's the teeter-totter? This thing's still pretty hot. Okay, do we stop the time or do I grind it? What do you think? Grind away. Everybody says grind, grind, grind. Okay, here we go. Big battery. Put some safety glasses on. Okay. Okay. Pull this one out. We'll grind the other one. Ooh, it got tight. I might have to do a little adjustment on this one. But might just be because I was trying to pull it out uneven too. Might have to make an adjustment on this one. We'll let it cool, see where we end up. Let's just grind away. Okay. Probably do a little bit better grinding if this wasn't for me. Okay, first things first. Okay, that's it. Do I want to keep the caulk running and do some adjustments? That's what we need to decide. I'm just curious here. Might have a little bit of a warp to this. We might have to fix it. Which isn't the end of the world. I'll show you how to fix it. Because like I said, we're gonna make mistakes. It's all about how we fix it. As far as size go, looks pretty dang good. Okay, what do we want to do? Conrad, should we do a little test of one right here? It's at this moment in time, do I expect this to be dead nuts perfect coming right out of the box? Well, I think this is where we need to have realistic expectations, right? And bang, that looks pretty good, but I think we can make a little minor adjustment. We'll figure out where the issue is. So the goal is to have these perfectly straight up and down, right? Which we're just looking, so it looks like this leg is pushed out a little bit. So let's identify, is this leg pushed in? I mean, we're talking, would this pass? Yes. Like I said, am I going for excellence? Yes. Okay, so I've noticed this leg is pushed out a little bit. What happened? What I mean by a little bit, I mean we're talking fingernails clip. I think I'm gonna have to pull it in. I don't know what happened here, but somewheres. But let's work on the flatness a little bit too. So I pull, I push. I pulled, I push. Like I said before, it's all about how you handle it. Is this going to leave the shop this way? Do I want to move it in this 3/32 of an inch? Let's just see if we can push it a little bit. I mean, we're just talking just a skosh. We'll check it. And that's all it takes, is just a little squeeze. Like, I have no shame saying I had to put a little squeeze on it to move it at 32nd. Whatever. Boy, that moved it almost right in spec. One more little squeeze, just a little bit. I mean, I'm barely putting any pressure on it. We'll check it for perpendicularity here in a minute. I know, I wish you guys could see this. I'm just barely moving it. We're talking just thousandths of an inch. It's a little squeeze. Oh. Well, how does it look from there, Conrad? I mean, you tell me. I mean, it looks pretty sweet, eh? I mean,
looks in spec.
It looks damn good. I mean, I am really happy. Where's my straight edge? Woo! Look at that. I mean, we're talking slices between there. I don't know if you guys can't see this. I'm pretty proud. This one might be a little bit off, but dang! For these legs to be completely unsupported out here, that's tough. So now what I want to check, should we hit the timer? We're going to hit flatness. Here, I might need to flex this a little bit. Let's just kick all these off to the ground. We'll come back to these later. Ugh. The problem of having a little table, it fills up really fast. We'll put them back when we're done. Like I said, I have some movement, I have some tolerance, and I'm going to use it. Because like I said, I would drive myself bonkers to try to dial this thing in. But what I'm trying for is I am striving for some excellence here. Okay, feel this one. This one teeter-totters a little bit. This is where having a flat surface is really important. A little bit. Let's just see if it passes. So this is 1/16 of an inch. So we make note of the time. Okay, so I hear just a little bit of teeter-totter. My 1/16 of an inch does not pass underneath of it. Okay, so technically this is in specification. But I want to fix it. But we're going to do that when I hit the stop time. Because technically these could go out the door just as it is. Okay, this one does not teeter-totter. This one's really flat. I can't hear anything. This one passes inspection. Okay, so I'm going to call stop. Okay, so let's hit stop on the time. Whew. How long did that take me, Conrad?
2 hours, 43 minutes total.
2 hours and 40, that was plus the 20.
That includes the 20.
Okay, and I would consider talking to the camera kind of slowing me down. I would say another 10 minutes or so, roughly. It's pretty good. So let's just think about this. $100, I would charge $500 for these two, just like everybody else would. $100 for material. And then that leaves me with a profit of $400. So that's literally over $100 an hour to do this job. That's pretty good money, right? I mean, in the days just getting started, we could do this again on another project. We could make another $300 and clear that pretty simple. But I want to stop the time, but I think we're going to keep learning here. I want to take some time and do some real QC, okay? But I want to do that on camera for a minute. I want to show how you can use the fixture table to QC these parts, okay? I would include this in the normal time, but I want to take my time, if that makes any sense. Okay? So this one, before we go any further, I noticed this one teeter-totters just a skosh. It's within spec, but I hear a little clinkety, clinkety, clinkety. It's not bad, but let's fix it. Let's go for excellence. So how can we fix that? Well, here's what I want to do. I think we're going to use, because this is a heavy-duty cast iron table, let's just put a little flex in it. Let's just get it back into spec, right? So I can see here that where's when you look at the frame, there's going to be a center line twist. It's either going to be here, here, or here, here. So let's find out where it is. Or let's isolate it. Is it the tube that's bowed that I didn't do a very good job? But having a flat surface is going to help me identify what's going on here. I just think this is I think I got a little twist. I got a little twist right here and here. So these two are high. So let's just flex it. I'm going to put a shim here. I'm going to put a shim here. I'm going to put shim there, shim there, shim there, and we're going to push down just with the clamp. I mean, we're just trying to just put a little bit of movement in this. Let's get rid of these. Okay. So let's scoot this to the edge of the table. Let's put a couple clamps down here. What we're going to do is we're just going to flex it just a skosh, and then we'll check the legs and see how that altered the legs. But we're human, we make mistakes, and I'm glad this came out just a little bit tweaked, right? Because this is the real world scenario, and if we don't have the tools to be able to identify problems and fix them, we're all human. Things happen. Who knows, there may be some grit on the table. I don't know. Okay, so what I want to do now is push down on this just a little bit. What I need is a big heavy duty clamp, something I can really just smash on. I'm going to put another clamp over here because we're really going to be flexing. This is where I tell people that you need a table that's a minimum of ½ of an inch thick, because you want to be able to use it like I'm going to use it right now. You're going to want to bend it. You're going to want to use it to flex or bend or push or pull. The 1/4 inch tables, they just don't have the oomph. Okay, I might have to go underneath here. Yeah, they just don't have the strength. The top flexes too much. I only need to go just a little bit. But this is where we're talking about QCing. If there's something wrong, how do you fix it? Okay. So I don't need to take the shims out from underneath of this. What I can do is just grab another shim, because I have a ½ inch shim under here, ½ inch shim, ½ inch shim. Now if I slip this ½ inch shim underneath here, I could see, oh man, I think we got it. That was it, we're done. That's all it took, was just a little bit of. So we're back to QCing. Having a flat table allows me to QC. Let's take a look. Oh, remember that this teeter-tottered? I don't know, maybe the microphone might pick this up. Fixed it. Now let's check the legs again after we tweaked it. We can pull a tape measure, but I don't think this is truly the right way to do it. We should put it back into our fixture over here. So it looks like everything's pushed out a little bit. Still within specifications. Let's check. So because we know this is a perfect square, let's just drop it in. So it's a little bit tight. It's a little tight. Just a little tight. Let's fix it. Like I said, oh. All right, so we're a little tight. At this point in time, I can choose to go for excellence, or I worry about it. What's Conrad think we should do? Should we go for perfection? Or do we call it okay? Do we do some more QCing? Let's see it fit back in the hole, I guess, huh? What's Conrad think we should do?
The plans call they can't be oversized?
I have a 1/16 of an inch over.
Over? Okay.
So that's kind of where I'm seeing I'm about a 1/16 of an inch over. So splayed just a little bit.
I mean, I'd say once it's in spec, it's ready to be shipped off.
It's ready to be shipped off. All right.
What the customer ordered.
Let's get it in spec then. We're just gonna pull the legs in just a skosh, and then we'll check perpendicularity. Make sure that we're not just pulling one leg in and but the base, you can check the base again. We'll just see if it was our legs tweaked. It would be nice to have the CMM here, but I'm literally trying to bend this in like 30 thousandths of an inch. Really. They're even right. Help if you go the right way, ding dong. Oh, sheesh. You're so close. It just wants to barely drop in. I mean, I'm being a little nuts here. I mean, look how this fits in. The frame fits in nice. Oh, I won't go in any more than that because my welds are sticking out. Looks pretty good. So let's check perpendicularity with the big square. Should we do that? We're having fun at this moment in time. We're just geeking out. Where's that big square at? Are there any questions coming through that I can answer as I'm doing this? Nothing really? Everybody's happy? So because I have welds in here, I'm going to use the 1/2-inch spacers, one on the bottom and one on the top. Okay, and I'm going to be able to use the table as the reference. Ooh, looks like I am definitely pulled out a little bit more than what I would like. Yeah, pulled out more than what I like. I would almost go to say that this is not in spec. They're all this. So what's happened is all the legs are splayed out. They're all perfectly even. They're just on the outer limits of my tolerance that I really want. So because they're all the same, I think I can just squeeze it with a clamp and pull it back. Which is not really what I'd like to do. I would like everything just to be dang perfect, but you know, what are you gonna do? The only reason why I'm able to do this is because everything's even. They're all splayed out just a skosh. This is interesting, you know. This is a really hard challenge. This is something that I think everybody should try. Man, this is so hard to do without a fixture table. I mean, I know it looks easy on camera, but it's funny, I didn't even move it. That one Boy, you really got to squeeze. You got to squeeze hard. Like I'm fighting for just for a few thousandths of an inch. But this goes to show, what do? You keep going, you give it to the customer, like what I got before, fix it. I'm actually really surprised that this moved this much. Okay. So where do we think it's moving at? I might have to cut it loose. If this was really bad, start over. So that one's strange. I bet you this is because I had those big, huge weld gaps. Bet you it really pulled. Let's just check it out here. Woo! Getting close. Woo! Nope. Well, it's crazy. Any suggestions from the audience? No? Everybody gone? Everybody's gone. Let's take a look. We want to get the camera in here? Nope. Yes. Pretty close. And we're talking pretty dang good. We did pretty good. I'm pretty happy with this. Splitting hairs. I'm getting too carried away. I like it. I like it a lot. Can you see anything, Conrad? I know it's probably hard for, this is where I wish, I don't know if you guys could see this, how straight they are with each other, perpendicularity. No, you probably can't see that. Really, really, really good. Well, I had to do a little tweak here and there, but nothing that's as far as flatness goes, I'm within spec. I like it. Now are we to size this way? This is where the CMM is nice. But if these legs were shifted left or right, this straight edge would not show that they are straight. Does that make sense? So that's one way to kind of confirm. And then two, if you don't have a flat surface, if you want to try this at home, a way you can check for flatness is let's just put them on each other. Because two flat surfaces, right? Two flat surfaces against each other, they're going to be flat. No matter if you turn them this way, then 90 degrees, flat. If they're warped, like a Pringle chip stack on top of each other real nice, one way. You turn them 90 degrees, they don't fit. So it's one way you can check to see if you got something flat. So let's just do this. Okay. Still a little teetery. Like I said before, nice and tight. Gonna turn it 90 degrees. We have a little bit. But so between the two, even between the two is the worst of the worst. So this is worst case scenario on this one, worst case scenario on this one. Here's a 1/16 of an inch, and it still does not go in between the two, right? So that's one way you can kind of check yourself if you don't have a super flat table, or if you want to try this at home. Okay, worst case, won't go. I think it's sweet. I would be happy letting this go to a customer, and I would know that they would be happy also. Okay? Learned a lot. Hopefully you guys saw some issues, some problems, how to work through them, and even if you do have problems, you can still be profitable. I think that's also the name of the game, is we're going to screw up, and how do we get back on our feet and fix it? So I'm glad I took the extra step and didn't do this the right way, and show you guys how you can straighten something out like this and get good results. I think we did good. All our weld seams are all facing the inside. This is a level of professionalism that goes the extra mile. See all my weld seams, they're all on the inside of the legs. They're all on the inside of the tubes. These are just things to look for when you're done. Okay, and this is a table, and it doesn't even teeter-totter on 4 legs. So we know the end conditions of our legs are good, nice and tight, tall. So if you guys would like to see more, I'll happily bring in the CMM machine. We can test them out. If we want to do some more quality control on another live feed, we can do that some more. If you guys have more questions, I would love to answer those at the Fireball Forum, because most of these live feed videos, all the comments kind of get lost after a long period of time. So documenting on the forum is going to be great. Then they're also searchable for anybody else who has the same questions as you guys do. I'm going to be there on the forum at the computer for the next hour or so after I take a quick break and a lunch, and I'll happily answer any questions you guys have in depth. And we can do this again if you want to see something else new or a different weldment, some try a new experiment. I'd like to see you guys try something like this too. I think this is a great application for if you're a student or a school, or this is a good test to give a fabricator if you're a weld shop. If you want to hire somebody, just tell them to make 2 of these things and just see what they come up with, right? So I think there's a lot of practicality to this, and you can learn a lot by just welding 8 pieces of metal together here. Any questions?
Last question. Is this in spec?
Is this in spec? This is in spec. Is it as perfect and as excellent as I want? No. But is it in spec? Yes. I would like to pull, I'm literally about 30 thousandths of an inch out. I would like to pull the legs in a little bit more, but technically this is in spec. It's at this moment in time where we say, do I take that little extra time and do I squeeze it? Do I cut the welds loose? As far as flatness goes, we are in spec flatness. We showed that before, and I showed one of them wasn't quite right. We fixed it. It was still in spec then too. And the name of the game is, am I happy with it as a fabricator? And I am. Like I said, we can put the legs back up to each other, and I can show you how close they are. We're literally splitting hairs. And one of the good things I notice is that this is an 1/8 inch wall material, and the leg does not exceed the wall thickness when they're together. So it's another visual inspection, where if we do the leg on those other fabricator shops, you could literally see it down inside the tube and there's a big gap. These are all little visual cues. Like I said, I'm a little bit wide, and that's why it doesn't drop into the fixture here, but I'm a little wide by like 30 thousandths of an inch. I can see like it's a 32nd, and that's why it won't drop in. I can choose to fix it, or I can leave it. What do you guys think I should do? Should I just keep tweaking on it and pull up the extra 30 thousandths, or do I call it good? There's a tolerance here for a reason, right? If we were to sit here for an hour, try to get it, that's just money getting thrown out the window. I think if you can get it within the tolerances and you can measure it and you know it's there, move on to the next job. That's what the tolerance is there for, right? But the goal is to get into tolerance as quickly as possible. and know and identify that you are there. But fixtures are telling me that I'm just off a little bit, and I'm okay with that, but it is a measurable distance. Okay, Conrad, what else? Any more questions?
No, just confirming with the chat that everything's in spec.
Okay. But overall, I think what I'll do is I'll have Conrad pull the camera off the tripod, and I'll just let him just do a quick walk around for you guys. Just get some B-roll of just seeing how everything lines up. I'll flip the legs over on the top so you guys can see what I'm talking about. Get you in a little closer, and we'll go from there, okay? So bear with us for a minute. I'll flip these over. Okay, so here's what I'm talking about. I'm just a little wide on these two right here. It's not even the material thickness. If I wanted to press on it a little more, I could probably squeeze it. But remember, I have an 1/8 of an inch. I can be a 16th left, 16th right. And I'm well within an 1/8 of an inch. Like this isn't even a question if this is in spec or not. So, like I can be an 1/8 of an inch oversized from this. Does that make sense? So I can be 20 and an 1/8. And you can visually see that I'm not even near that. As far as perpendicularity, this is one of the a lot of people have a lot of questions about. Here, take a look at this, Conrad. So this is a 24-inch straight edge. Can you see? Probably can't, but there's barely any gap in between there. This one better to see. So they're very straight with each other. Pretty happy with that. Like I said, tolerance is there for a reason. Let's use them. And this is really hard because all these legs aren't controlled. There's nothing holding them apart. But yeah, I wish the other fab shops could have produced something like this. Then it would have been unquestionable that they could achieve this level of accuracy, but without a fixture table. Boy, this would be hard without a fixture table. It's even hard with a fixture table. There's no denying that. I just couldn't imagine not having this tool to do this with. Okay, any more questions coming through? No, everybody's silent. I silenced the audience. Whoa, everything's good. Okay, guys, go to the forum. Let's talk some more. Let's chit chat some more. If there's questions about the table, how to fixture, if you guys have something else you want to see me make, send some plans up there and maybe we'll do it on another live feed. This is fun stuff. Okay, I'll see you guys at the forum. Thank you guys for watching.